So students, welcome to the session. In the last few examples, we have seen how we can minimize the cost function. And the cost function should be treated as a function in general, and you know how to find out the maximum or minimum value of any function. The simple approach is whatever function is given to you, find out its first derivative and equate it equals to 0 and then solve it. When you will equate the first derivative is equals to 0, it will be treated as an equation. So naturally, you will have to solve this equation. And when you will solve this equation, you will get certain stationary values or stationary points, means some values of x. And these stationary points, in fact, will give you the point of maxima or the point of minimum. So among all these stationary points, which point is a point of maxima and which point is a point of minima, this can be tested by using the second derivative. So find out the second derivative of the given function and put this stationary value in the given function. If the second derivative is negative, that is less than 0, then the given stationary point is called the point of maxima. Likewise, if the second derivative comes out to be positive, that is greater or equals to 0, then the given stationary point will be treated as minima. So this is how we can find out the maximum and minimum value of any function. In the last 2 or 3 examples, we have seen how we can minimize our cost function. So in a sequence, let us take this example also. If the total cost function is given by this 0.005x cube minus 0.02x square minus 30x plus 5000, where x simply represents the output, right? Determine the average cost function. Let us see, this example is very much similar to the example earlier we have already done. Average cost function, you know what is average cost function? Simply the total cost function should be divided by the output. That is, by x, you will get the average cost function. See, this is your cost function given cx. Then by definition, the average cost is what? Divide the total cost function by the quantity or by output x, you will get the average cost function. So when you will divide the total cost function by x, you will get 0.005x square minus 0.02x minus 30 plus 5000 divided by x. Right. The new thing is what? Slope of AC, means slope of the average cost. Actually, when we have discussed about derivatives, I have given you only one perspective. Being students of commerce and business, in your perspective, derivative simply represents the rate of change of the dependent variable whenever a small change is being done in the dependent variable. But another representation or another perspective of the derivative is what? It also represents the angle of a tangent on any curve, means slope. So slope means the derivative. So whenever, be careful and keep in your mind, whenever you want to calculate the slope of any type of cost function, whether the total cost function, average cost function, or the marginal cost function, simply find out its first derivative. The first derivative of any function will represent its slope, right? The slope of AC means slope of average cost function. So this is our average cost function. Find out its derivative. So derivative of the average cost function is 0.010x minus 0.02 minus derivative of 500 upon x, you will get as 5000 upon x, you will get as minus 5000 upon x square. So this is simply what? This is the derivative of the average cost function. And derivative of any function simply represents its slope, right? Third part is what? Marginal cost function. You know, whenever you have given the total cost function, its simple derivative, that is the first derivative, will represent its marginal cost function. So this is your Cx is this. Find out its first derivative, that is dc over dx. dc over dx is called the marginal cost function. So this is your marginal cost function, 0.015 x square minus 0.04 x minus 30. This is the marginal cost function. The fourth is what? Slope of MC, marginal cost. So again, slope means what? Simply the derivative represent the slope of any function, right? So if this is your marginal cost function, then its derivative will represent its slope. So find out its derivative, you will get its slope. So its slope is coming out to be 0.03x minus 0.04. The 30 is a constant because its derivative will be 0. So what is important here, the fifth portion or the fifth part is somehow different rather than the remaining exercises we had already done. The value of x for which AVC is equals to MVC. Value of x means the quantity of x, the output x. What should be the output of x so that the average variable cost should be equals to marginal variable cost, right? So C, average variable cost means AVC, right? We know the total cost function is simply the sum of the variable cost plus the fixed cost. We have already discussed fixed cost means a cost which never changes, and the variable cost is a cost which changes as the level of production also changes. So average variable cost can be calculated by what? First calculate the variable cost, that is VC. Then we will take its average, right? So VC means the variable cost. Variable cost is what? The total cost function represents the sum of the variable cost plus fixed cost. So here our total cost function is this, right? So what is variable here? 0.005 x cube minus 0.02 x square minus 30x. This portion depends upon x because it contains x. Whenever x will change, this portion will also change. 5,000 is a fixed number, so it should be treated as a fixed cost. So this portion, that is variable cost, should be considered as the variable cost. So variable cost will be equals to 0.005 x power 3 minus 0.02 x square minus 30x. This is your variable cost, right? So if this is a variable cost, then we can take its average. Average means we will divide this function by the output x. So AVC is equals to the variable cost divided by x. So what you will get here? 0.005 x square is left minus 0.02 x left minus 30. So this is your average variable cost, right? Take this, is coming out to be the same. Now, this is your average variable cost. Similarly, we will calculate the marginal variable cost. So this is our variable cost. How we can calculate its marginal variable cost? You know the marginal means simply find out its derivative. So if we calculate the derivative of this, we will get as marginal variable cost. So its derivative is what? Find out its derivative. You will get as 0.015 x square minus 0.04 x minus 30, right? And what is given in the question, average variable cost should be equals to marginal variable cost. So AVC is equals to MVC, means this quantity should be equals to this quantity, right? See, this is equals to this. Simplify these two, you will get the value of x as 2. It means if the output is 2, then the firm's average variable cost and the marginal variable cost both will remain same. right? So let us take this question also. This is also a very good important question. Let n be the number of workers employed. The average cost of production is given by C is equals to 24n plus 3 upon 2n minus 4. Look at this. Show that at n is equals to this, C is minimum. What is the difference? Till now, we have taken C as a function of X, right? X is the quantity demanded in the market. But here, in place of X, we are having N. N is the quantity of demanded in the market and C is its respective cost. So be careful, don't be confused. Simply, X is being replaced by N. Or you can say that N is treated as the quantity demanded or the output, right? So what you have to show that C is equals to 24n plus 3 upon 2n minus 4. This will be minimum for n is equals to 4, 1 upon 4. This is a mixed friction, 4, 1 upon 4. For this value of n, this C will be minimum. Then you have also been asked, will you then advise to employ 4 or 5 workers? So naturally, if we are concerned with the cost of a firm, then as a manager, our objective is what? We will opt an option which minimizes our cost. If the cost is minimum, then we will employ the number of workers accordingly, right? We cannot maximize the cost. If the cost is maximum, then the revenue or the profit will also change. So see, for this value of n, this function is minimum. Simple procedure. What is this? The average cost is given by this. The only difference is what? It is in terms of n, not x. This is your this. So for finding out the stationary points, what is the condition? dc over dn should be equals to 0. What is the value of dc over dn? Here n should be treated as independent. C should be treated as dependent. So derivative of 24n will become 24. If we would have been 24x, then its derivative would be 24. So simply n is being replaced by x. And the rest is as usual. Plus 3 upon 2. 1 upon n minus 4. What will happen with this? 1 upon n minus 4. Find out its derivative. 1 upon n minus 4. This can be written as n minus 4 raised to the power minus 1. Using the formula of x raised to the power n, you will get here minus 1 n minus 4 raised to the power minus 2. And this is equals to what? 1 upon n minus 4 power 2. Right? So what you will get? This will become minus. Use this minus. This value will become 24 minus 3 by 2 into n minus 4 power 2. Right? The same thing. And the condition is what? For finding out the stationary points, dc over dn should be equals to 0. So if this is equals to 0, then what will happen? What is the value of n? See, 3 upon 2 n minus 4, its power 2, this is equals to 24, right? So 3, 8, the 24. What we are getting here? 1 upon n minus 4 power 2, this is equals to 1, 6. 16, clear? Up to here, and everything is clear. Now revert this. So the value of n minus 4 square will be what? 1 upon 1, 6. N minus 4 will be equals to plus minus 1 upon 4, right? So here, if we take n minus 4 is equals to 1 upon 4, case 1. Case 2, n minus 4 can be taken as minus 1 upon 4, right? So in this case, the value of n will come out to be 4, 1 upon 4. And in this case, the value of n will come out to be 3, 1 upon 4. So these are the two values of n which we can calculate by using the simple concept of maxima and minima. And these two values of n are known as stationary points, right? And you know, these stationary points will give you the point of maxima or the point of minimum. Now see whether this or this. What has been asked in the question? In the question you have been asked, show that n is equals to 4, 1 upon 4, c is minimum. So for this value of n, we have to show that c is minimum. So for this, what we will do, find out the second derivative, right? And put n is equals to 4, 1 upon 4, it should be negative. So what is the value of second derivative? D square c divided by dn square. This is our first derivative. This is the value of 3 divided by n minus 4, 3. This is your second derivative. If we put n is equals to this, then d square c upon d n square is coming out to be greater than 0. Therefore, c is minimum if the value of n is equals to 1 upon 4. And c at n is equals to 3, 1 upon 3, 3 upon 4. Sorry, this value is 3 and 3 upon 4. I'm sorry, this, right? For this, it is coming out to be negative. So C is maximum. So we cannot talk about maximization in terms of the cost. So for C, for n is equals to 4, 1 upon 4, the total cost is minimum. Therefore, what is the requirement? 4 and 1 upon 4. Will you then advise to employ 4 or 5 workers? What we have concluded, for this value of n, the cost is minimum. This means, what is this number? Therefore, either 5 workers or 4 full-time and 1 part-time worker are to be employed. So 4, 1 upon 4. In terms of the human beings, we can say that they can be considered either 5 workers or 4 workers in complete sense and 1 worker in part-time. So this is how you can also decide how many workers should be employed, right? After having the idea of the cost function, I have told you the second important function is revenue function. And we have discussed in the very beginning that 2 kinds of cash flow we can talk about. One, cash flow which is going out of the firm. 2, cash flow which is coming inside the firm. So the cash flow which is going outside the firm, out cash flow, that is known as the cost incurred. The cash flow which is coming inside the firm, that is known as the revenue generated by the firm. And you know the difference of these two. We will consider the next topic as a profit, right? So what is revenue? Before defining the marginal revenue and average revenue, we will run on the verbatim pattern as we run in case of the cost function. So before defining the marginal revenue and average revenue, first we should define the revenue. Then we will define the total revenue, right? So revenue function is what? If that is defined as, if X units of a commodity are sold at a rate of say rupees P per unit, then the total revenue received by the seller is a function of X and is therefore called the revenue function, which is denoted as R. R is equals to P into X. P is the price per unit of the commodity and X the number of commodities sold. You all know from the very beginning, revenue means the price per unit of a commodity. If it is being multiplied with number of commodities sold, the product of these two gives us revenue. So the same terminology we are using here, R is equals to PX. This is the simple formula to calculate the revenue. So if R is equals to PX, this is the formula of the revenue. We know from the demand law, what is this? P is equals to Fx. Demand law means price depends upon the quantity demanded in the market. Whenever the quantity demanded in the market will increase, the price will decrease accordingly and vice versa. So P is equals to Fx. This is known as the demand law or demand function. So put the value of P in R, what you will get, R is equals to P is Fx and then X. This is your revenue function. Rx we are getting as xfx. So simply Rx is now a function of x, that is the number of commodities sold. Now if this is Rx, this is the revenue function or the total revenue function. Now we can differentiate it to find out dr over dx. Differentiating revenue function with respect to x, this is what this will be known as the marginal revenue. In the same way, if you have given any function, find out its first derivative, it will represent its marginalized constant. The total cost function is differentiated, we get the marginal cost. If the total revenue function is differentiated once, we will get the marginal revenue. So derivative of this, that is dr over dx, see here x into fx. Here two functions are being multiplied. One function is x, the other function is fx. So we can find out its derivative by simply using the product rule. So see, first function as it is, derivative of second f dash x plus derivative of x is 1 and fx as it is. So dr over dx, that is known as the marginal revenue. This is called as the marginal revenue of the given function, right? By definition of the average revenue. So if this is your marginal revenue, then how we can find out the average revenue? You know, the average revenue is always equals to total revenue divided by the number of commodities sold. So average revenue is equals to R divided by X. So put the value of R. R is equals to, if you will put R is equals to Px, then you will get here P. If you will put R is equals to XFX, then you will get Fx. So this is how we can determine total revenue function, then its marginal revenue function, and finally the average revenue function. Now look at from these two revenue functions, average and marginal. If we take the difference of the marginal and average revenue function, this is your marginal revenue function is x f dash x plus fx. And the average revenue function is coming out to be fx. So if we take the difference of these two, that is marginal revenue minus average revenue, we are getting x f dash x. This shows that marginal revenue and average revenue differ by x f dash x. F dash x is the derivative of fx. Look at the last line. If f dash x is negative, less r equals to 0, whenever x is positive, then mr minus ar, this will be also negative. That is, the marginal revenue curve is always below the average revenue curve unless it coincides with it, right? Now let us take some examples. Before proceeding some examples, we can determine the revenue under two basic conditions. Actually, what is the meaning of two basic conditions? A brief marginal analysis of a firm operating under perfect competition as well as under monopoly. And I think you all are known with these two terms. Under perfect competition, take the first case. What is the meaning of under perfect competition? Under perfect competition, under perfect competitions, our basic assumptions are there are many firms producing the homogeneous products. So if there are many firms producing the homogeneous products, the prices are not being decided by the producer, rather the prices are being decided by the market. And naturally, if prices are being decided by the market, then the prices are completely independent of the quantity demanded in the market. Are you getting the point? If the prices of a commodity is being decided by the market, then it is immaterial whether the amount of output or quantity demanded in the market is increasing or decreasing. It doesn't make any difference. It doesn't make any impact. Price is completely determined by the market. It means P is completely independent on X. So if P is completely independent on X, it means what? When we will find out its derivative, look at this. If P is completely independent on X means what? P should be treated as a constant. not a variable, because P is independent of X. X is a variable. So P should be treated as a constant. So if P is a constant, then its derivative will be what? Its derivative will be P, because X, derivative of X is 1. So R is equals to Px, and if P is independent of X, then marginal revenue is equals to P. Marginal revenue means find out its derivative, dr over dx, we will get as P. Means the marginal revenue and the price of the commodity both are same under perfect competition, right? Case 2 is what? Case 2 is the case of monopoly. What is the meaning of monopoly? Monopoly means there is only a single product available in the market, right? There is no other substitute. So naturally, if there is only a single product available in the market, like a railway is the best example of the monopoly. So naturally, if there is only single product available in the market, then what will happen? Then the prices of the commodity are not being decided by the market. Rather, they are being decided by the producer. And naturally, if the prices are being decided by the producer, then it's simple choice of the producer how much prices he or she will decide. And naturally, he or she will decide the prices accordingly, as the profit must be maximum. So in this case, what happens? Prices are being decided by the producer. So prices depends upon the quantity demanded or supplied in the market. So P depends on X. So P should be treated as a variable. So now what will happen? If Rx is equals to Px in case 1, under perfect competition, P should be treated as a constant, because P is independent of X. The quantity demanded in the market is increasing or decreasing, but P will remain the fixed. It can never change. But on the other hand, under monopoly, what is happening? Prices are being decided by the producer or the manufacturer. So P completely depends upon X. So P should be treated as a variable, not a constant. So naturally, if R is equals to Px, P is a variable and X is also a variable. So naturally, this is the product of two functions. We can find out the marginal revenue in this case using the product rule. X, first function, derivative of P is dP over dx, plus derivative of X is 1 and P. So marginal revenue becomes X dP over dx plus P, because P and X both are considered as a variable, right? So try to understand the difference between these two conditions under perfect competition as well as under monopoly. Now let us take some examples. See, this is the very simplest case. We will run on the verbatim pattern as we did in case of the cost function. What is the difference? In case of cost function, we were trying to minimize it because cost is always minimized. But in case of revenue, we will always try to maximize it. So before proceeding this example, let me explain you once more what is the process of finding out the maximum or minimum value of any function. So be careful here. Here our function is the revenue. So we are not going to minimize it. We will always maximize it. And what is the requirement for maximization of a function? Whatever function you have given, find out its first derivative and then equate it to 0, right? When you will equate it to 0, you will get an equation. Solve this equation. This equation will give you certain points. These points are considered as the point of maxima or the point of minimum, right? The stationary points. You can also call them as stationary points. Now, these stationary points will give you the point of maxima or point of minima. To check which point is giving you the point of maxima, we are not concerned here in case of revenue function with the minima. We are directly concerned with the case of maxima. So we have to maximize it because In case of the cost function, we have already minimized it, right? So we will always try to maximize our revenue function. So after getting the stationary points, find out the second derivative of the given function and put the stationary points in the second derivative. If second derivative comes out to be negative, then that stationary point will be considered as the point of maximum, right? We can use the same procedure. Say in this example, the revenue function for a product of a firm is given by Rx is equals to minus 50x square plus 500x. This is the revenue function which is given to you. Determine the value of x which maximizes the total revenue. Yani how much quantity must be sold so that the revenue should be maximum. X means how much units of the commodity are being sold. So naturally the revenue function is given Rx is equals to minus 50x square plus 500x. What is the first step? Find out its derivative, that is dr over dx. So naturally dr over dx will be what? Minus 100x plus 500. And we know for maximization of the total revenue, first derivative should be equals to 0, right? So this is equals to 0. dr over dx is 0. Now this means minus 100x plus 500 should be equals to 0. So if minus 100x plus 500 is equals to 0, x is coming out to be 5, right? This is the value of x, right? Now what is left? X is equals to 5 is giving you your stationary point, right? You know this, and this stationary point will give you the point of maxima. We are not concerned with the minima because our function is revenue. Now for this, whether this maximizes our total revenue or not, we will find out the second derivative. And naturally the second derivative of this is what? Look at the second derivative of this will be what? Minus 100, derivative of x is 1 and 500 is a constant. So its derivative will be 0, right? So d2r over dx2 is minus 100. And this is a constant number if x is 5 or any value of x, because it is coming out to be minus 100. It is independent of x. So this is negative. It shows that if 5 units of a commodity are being sold, then the the revenue of the firm will be maximum. Hence, the total revenue is maximum if x is equals to 5, right? What does it mean? What is the meaning of minus 100? Look at this. Minus 100 is simply a constant. What does it show? It simply shows that whatever x we have, here we are having x is equals to 5, the revenue is maximum. You can change the value of x, even then the revenue will be maximum because the second derivative is coming out to be constant. It is independent of x. If x is there, then the value of the second derivative will also change, right? So it shows that for any number of commodities are being sold, even then the revenue of the firm will be maximum. Okay. So students, I think we should stop it here and we will continue the remaining portion in the next lecture.